Hi, good day. Here we go again. In one of my last videos, we learned how to do a single finger swipe. And in that code, we basically just check for a start position and end position, and start time, end time, because we used a threshold distance and a threshold speed to detect when a swipe occurred, and we showed it visually on screen with a change of our background color. I wanted to try to do a multi-finger swipe because I remembered sometimes you can use 3 fingers to swipe on a screen, and I just wanted to apply that in that sort of gesture. And of course this is a multi-touch gesture, 3-finger gesture, so I'm going to build on the multi-touch. So I'm going to copy the code from the multi-touch script, Control A, Control C, and let's create a new script. Actually, let's create a new scene, and let's make it a control scene to make life easier. Let's switch to 2D scene, and as you can see here, we already have the layout. Let's just add a color rect for the background and make that color rect full rect. And let's change the name of the control here and just call it 3-finger swipe scene as a descriptive name, and let's save that. Let's add a script, and let's just Control A and Control V to paste the code that we copied from the multi-touch. Save that. Okay, let's start by removing the print statement. Save this, and we already have a dictionary that tracks the touches and the indices of the touches. I also want to add another dictionary that will track the starting positions of those touches. So let's put var start position colon equal to open close brackets. Save. And wherever we have the touch event, we're just going to add the start positions. Similar event index. Remember, we just want the start indices, so we can use it in calculations later on, and that will be equal to the event position, similar, because basically it's the same information we want when the touch has started. When the start touch has ended, we want to remove it as well. And let me just change the color of the circle. I'm just going to use black now, just to identify it from the other projects that we did. And let's save, and let's run a quick test and see what happens. But before we do that, let's change the in project settings. Let's change our default startup file to 3-finger scene, and let's run. So there's an error. Oh yes, we copied and pasted, but we're not using a Node 2D anymore. We're using a control, so we need to change extends control. This is why it's good to test now and then. There we go. It seems to be working. But when I click, I don't see the circle. The code is similar to the last code, so I don't think it's a problem with the code. It might be something to do with the z-index. The z-index is basically the layers in which the graphics on any program is enacted. Usually default index is z-index of 0, and as you go up it's z-index 1, 2, 3. So anything higher than 0 will be placed above 0. But if there's anything like our color rect here that is so large, it will occlude the circles like it did here if the z-index is lower than the color rect. Now they're probably both on the same z-index, but because it seems that the color rect is being drawn after the circles, so that the color rect covers the circles. So one easy fix, you can fix it via code, but we can just click the correct here, go into the inspector and look at ordering and the canvas items, look at ordering, and let's just drop its z index to -1, and that should fix the problem. Let's save this and try it out. And there we go. We can see the circle being drawn. Okay, how we're going to approach this is we're basically going to do a 3-finger check again and take the average of the 3 fingers, which is not the most precise way to test it, but it's good enough for simple swipe checking. So at the bottom here, let's just, like we did in the other code, let's just put 3-finger check and close brackets. So we're going to do a 3-finger check, and that's, of course, you have to write code for 3-finger check. So function 3-finger check, open, close, and let's just pass for now. Okay, so let's just check for if it's 3 fingers that's touching. So we're going to use the touches. If touches.size is equal to, double equal to 3 fingers, we want to do, in our case, we want to find the average of the starting points and the average of the current points, the ending points. So let's create some variables here. Let's say var average start is equal to, we can do the calculations in here, or I think it's a better idea to create an average function separately. So let's go below this and let's create an average function, and we'll come back and fix that. So let's say function, and it's the average of 3 points. So let's just call it average point PTS. I hope you can remember what that means. I'm trying to be descriptive and short at the same time. And we're going to input an array of the points. So let's call it points, and let's just type it as an array so we won't make any mistakes. And what this is going to do, this is going to return a vector 2, an average, which is a vector 2. So let's say var average is total over the number of items. So let's just say var total is equal to, let's just give it a value for now. We can always change this up. Vector 2 dot 0. Of course, we're going to use this in the function, and it's going to change as we go along. We're just initializing it here. And let's say for p, or you can say for point in points, p in points. Remember, we input in the array of the points here. So p is just one item, one index. The total will be adding all. So total will be, we're starting with 0 plus equal, which is the same as saying total is equal to total plus whatever we're adding, plus equal p. And we're going to return, don't forget to go back one. Remember, we're going to return a vector 2. That will be our average vector 2. So that will be the total divided by how many points it is. Points dot size, and that's our average. So let's add it in here. So average start will be average points of our start position values. Remember, it's just 3 values, so it's going to work out as we want it to, because we said if touches size is equal to 3, so we're keeping that at 3. And let's say our average current is equal to the average points again, and this will be where we ended up, will be our touches, where the touches ended. So it will be the ending value of those touches, which will be the last continuous value before the calculation. And let's add spaces here. And we want something like the average movement vector of these 3 points. So let's just call it movement vector. It's a new variable, so let's just declare it. Is equal to, so our average movement will be the last movement, which is average current minus average start. So it's going to be average current minus average start. And we're going to use that information to get a distance that was traveled, well, the average distance that is, in our case. And that will be movement vector that we just calculated dot length, which gives you the length of that vector. So just like in the other code, about our average direction, that is correct, will also be the movement vector normalized, like we did in previous examples. And that's basically it. Let's just add a threshold like we did before. Remember, we're not going to use speed, we're just using distance, because having 3 fingers is what will validate that this is a swipe we want to do. So we don't need to validate with speed or anything, because it could be a slow swipe for all we care. If the distance is more than 100, so we want the average distance to move at least more than 100 before it registers as a swipe. Let's create a new function called check swipe, maybe chk swipe, swipe. We're going to check the swipe, and maybe you just pass in the direction. Depending on what direction, we can have some visual feedback, like the color rect change in color. So let's just say, so this will be our average direction. And of course it's showing an error because we don't have a check swipe function. Let's create a check swipe function. Function check swipe. Yes, we have to add a distance as a parameter. And let's just put pass for now. We'll come back to this. If we go back into the swipe screen, the single finger swipe, we'll see that we had visual feedback for when there was a swipe. So let's just copy this, and we could probably add more. Control C, put it in the 3 finger check swipe, Control V. And the if here is in the wrong position. Let's just move this back 1 indent, and let's just move this back another indent here. And I see some red arrows here. Oh yes, because I have direction here, but I made a mistake and put distance here. Check swipe has a parameter of direction. My mistake. So let's just put direction just to less corrections. And my spelling, as usual, is beautiful. And the error is gone. Let's save this. Now remember, I was saying that in the single finger swipe that you can also swipe on the y-axis. Let's just add some more code for that, and we'll change it up to the y-axis. So let's just copy these two, Control T and Control V, and let's change this to y, and let's change this to y. So this is going to check for movement on the y-axis, and we're just going to use the same threshold angles like as we did before. And since this is 0.7, this will be moving down, because remember, in Godot, a positive y value is downwards, and this will be up -7. And let's give it some different colors. Something light so the black will show up on it. Let's some sort of green maybe. Is it a light green? Yeah, and orange maybe. I hope orange is light enough. Yeah, that should be alright. And that's the end of the code. All we got to do now is test it out. We have swipe detection, an average swipe detection. Of course, it's not going to check if all the points were parallel. It's just going to give you an average, and once the average passes the threshold of 100, you're going to get a swipe in that direction, which gives you a visual feedback of color change of the colorect. It's not going to work if we run it in the debug, because this requires 3-finger swiping. So I'll have to run it on my phone. So let me get that set up and we'll test it out. Okay, so it seems to be starting on my phone. As you can see here, there's a white screen. That's our colorect. And I'm going to put 3 fingers. Actually, let me put 1 finger. There's no change. 2 fingers. There's no change. 3 fingers. There's a change in color. As we specified, we wanted the change to be done. Let me reset that to up so I can see if I move down if there's a change. If I use 4 fingers and I pull down, there's no change, but if I remove 1 finger, it makes it 3 fingers again, and there's a change. So that's fine. Remember, I was saying it's just an average, so it's not a precise measurement. Let's just say, let's move this back up. 2 fingers and 1, 3, and let's move this finger down. And you notice after some point, the distance moved by the top finger makes the average of the 3 fingers surpass the threshold of the 100. And that's why I'm saying it's not precise, because the code is not making sure that all fingers are parallel. You can write code for that, but I think that's overkill for a simple swipe. I hope you enjoyed this video. It was fairly simple because we built on the last projects that we did. And if you realize, it's not so hard to implement swipe, 3-finger swipe or multiple finger swipe in Godot. See you in the next one.